everybody, and welcome to Facts Machine, a show by and for people who are curious about everything, especially the things that make them laugh. I'm joined tonight for a show all about astronomy by two wonderful guests and one every-time host. First of those guests, Dr. Moiya McTier. Now, Moiya, I actually, when I showed you the art for this show, before I'd even gotten to tell you about the cool little things I'd added to it in Adobe Illustrator, you pointed out to me something very fun. What is that?
Yeah, I said, I think, told me, I pulled from the Hubble Deep Field image, and I was like, I can tell that's not the Hubble Deep Field image because the point spread function is different. The spikes on the stars, that's not what Hubble stars spikes look like.
It was also the little lens flares I added around the logo.
Yeah, I was like, that doesn't quite look like scientific data.
You are both an astrophysicist and a folklorist. So how do those two things come to be in like one, scholar and professional?
I'm also bisexual, and I'm bad at making decisions. I found astronomy in college in my sophomore year. I was always a mythology nerd, and then I went to the heads of both departments in college and said, "You both want me," and they said,
the experience
yes.
of being bisexual.
It's the way, friends. And then I refused to choose, and I studied both of them, and then wrote a science fiction novel that was set on a real exoplanet that I studied. That's my expertise, exoplanets in different parts of the galaxy. And the plot of the novel was based on the Hawaiian sovereignty movement. I went to Hawaii and talked to some native Hawaiians, and it was a cool time.
It is an extremely cool book that I have read and plugged on our podcast many, many times. And it is just like on a Google Drive that Moiya can send to you if you're interested.
It's on my website. You can all find it.
for sure. But Moiya, since then you have written another book.
An
Would you like to tell us
actual
about
book.
that?
Yeah, I wrote a book. It came out in 2022. Oh my God, over a year ago.
Yep.
And it is a story of the universe from the Big Bang to its eventual end, but it's all told from the perspective of our very sassy, bitchy galaxy. My favorite review of the book said, "This is for you if you've ever wanted to get dommed by the universe."
Yeah, that person must have listened to the audiobook, which is read by you. So it was a really complete experience, I'm sure.
A multi-sensory experience, yes.
All right. Well, thank you, Moiya, for joining us. We're really glad you're here. And we're also very glad to be joined by Dr. Mark Popinchalk.
Wow. Thanks, Noah.
So, Mark, you are an astronomer, and we'll talk tons about that throughout the show. But
yes.
you included something when I asked for your performer bio, and I noticed that it was also in other performances you've done. Your bio included that your favorite color is sky-blue-pink.
Yes.
Can you tell me why?
Yeah. It's because of my mother, who's here tonight. Everyone.
That's sweet.
Yeah, and it's the color right around sunset where actually some light's hitting the clouds and the clouds are pink and there's a blue sky behind it, and it's really two colors at once kind of thing, so it's a little bit cheating, but it's just, it's a really nice color, and I like to make people aware of it, I think.
Yeah, we definitely need to raise awareness. Of
sky blue paint.
Yeah. Speaking of bisexuality, I think that's awesome.
It would work well. You should look into it.
I mean, maybe the sky is just the bisexual icon we've all been looking for.
Oh.
But specifically at sunset.
Now imagine this vibe, but in your ears for 13 hours. That's the audiobook of the Milky Way.
But that's also when you ask the sun, do you want it to be night or day? And it's like, I mean, why not both?
You're right.
I know none of you know who that is yet, but we'll get to him. So, okay. So, Mark, just on that topic, you mentioned your mom was with us. So is this connection to sky blue pink? Is that what got you interested in the sky?
Not at all.
Oh, okay.
No. No. I have been at the American Museum of Natural History for 10 years now. That's where I'm at right now.
Heard of it.
As a postdoc, but I started in the education department. And have been a science educator there for 4 years before I went and got my PhD in astronomy. And I thank you for introducing me as doctor, because one year at least after you defend, I think you force people to introduce you as doctor. So
yes.
I'm a doctor now, everyone.
Yay!
Thank you, yeah.
At least 1 year.
At least 1 year. I'm going to force the audience to applaud for me, at least. Yeah, and I study how old stars are, looking at how they change over time, and young stars spin really fast, and old stars spin down, and I just measure how quickly stars spin, basically.
Very cool. So our final person tonight is not actually a guest. It's fully one of the hosts of the show, but we alternate who's standing up here and who's going to tell us something about themselves. So Dr. Rob Frawley, everybody.
Hello. Yes. Thank you for coming. Thanks.
So, Rob, what are your space science bona fides?
So I live in space. And nice Latin, yeah.
You are space.
Yeah, I am starred stuff. Somebody said that, and you can Google it. Yeah. That should be enough.
In terms of your space bona fides.
Oh. I see what he did there. Because so I study bones, and that's bona fide. And bones are from space in the same way that I am.
That's true?
Yeah.
That's true? Mm-hmm. Okay. Thank you all to the three of you for joining us tonight. And so what we're going to do is our guests are going to tell two fascinating stories about really interesting things that they've learned. But first up tonight, please welcome to the mic, Dr. Mark Popinchalk.
Before we started, Noah made sure to say, "Don't forget to leave the clicker." Great. All right. Hi, everyone. This is me. I'm Dr. Mark Popinchalk. I'm at the American Museum of Natural History, and I want to invite you all to a party I'm going to have in 252 million years. Okay? And this is very important. And before I tell you about that, you have to understand that I like to party. And this is my college experience. Some of the people I went to college, parents, don't worry, it worked out. But I like to party, but I've never had the perfect party.
Podcast listeners, can I just say that was you in an apron,
Yes.
period, hard stop, and a paper bag, and I don't even know. But so costumes, let's say.
Is
Yes.
that a pyramid on your head?
I don't remember that moment. Frivolous party going, let's call it that. But yes, I've never had my ideal party, and I think an ideal party is one where everyone's invited. And I don't just want to invite all my friends, I want to invite the whole world to this party. Okay, I want everybody in the world partying at the same time. And the only way I think to do this is to have a New Year's party where everyone is enjoying New Year's together. The issue is everybody has a New Year's party, but they're all at different times because they use different kinds of calendars, right? There's kind of a lunar calendar and an orbital calendar. And the lunar calendar is based on the number of lunar months or moonths. Let's work the word backwards to moonth. That's where it comes from. Yeah, exactly. And so this is the number of orbits the moon takes around the Earth. Okay, and so they say 12 orbits, that's a year. Versus, say, our kind of what I call the orbital calendar, where it's 365 days, but then we throw in a fourth one, an extra one every 4 years or so, just to make it even. So we've got these two different calendars, and the fact of the matter is, I want them to agree so badly. But they don't. They don't agree at all, because there's 12.36 moonths in a year. It never lands just right. They're never going to line up.
Should we occasionally have a leap month?
Not what I'm going to propose in a second, all right?
They used to have leap months.
They used to have leap moons?
Yeah, I mean, well, like the Mesopotamians had leap moons. The Egyptians had this special time at the end of the year, separate from the rest, where you weren't supposed to work. It was a bad time.
Nice.
Just to make up for the difference between something divisible by 12. And
it's essentially 10 days. There's basically 10 extra days depending on which calendar you use, and so that would be great, a 10-day vacation.
A leap month sounds like a British unit already. It's ready.
It's the Imperials.
But I'm an astronomer, and I'm not satisfied with the kind of orbits that are happening now, so I'm willing to travel backwards in time. I want to go back and find time, or forward in time, when there are exact number of moonths in a year, when there might be 14 moonths, or 13 moonths, or 12 moonths in a year, and that would be a true Happy New Year, where everyone can party. And so as I told you, just to finish my dissertation, and a few months beforehand, I decided I'm going to write an April Fool's Day paper that explains when this happened in the past.
Did you make this in LaTeX or whatever?
No, this is an actual paper that I wrote.
do y'all know about this? Astronomers write April Fool's Day
Yeah.
papers that are ridiculous.
It's great.
And they publish them.
Yeah, they spend way too much time on it. They're like, I could have been working, but I made a joke. And this is the joke.
Knowing astronomers, you would just call this the PPNT
Yeah.
HNYLOEEAIM.
Some
Thank you.
middle letters.
Yeah, I refrained from a ridiculous acronym for this.
I'm just so mad I did this in biology, but we don't have a culture of doing that, so it was just lost.
We've got lots of cultures. That's a joke for the biologists.
Yeah.
That's a joke for the biologist out there.
Yeah. All right, so I wanted to find out when these true Happy New Years have happened. And to understand that, we have to understand the Earth, Moon, and Sun system, because this is what's defining these kind of orbits. So a year is defined by the distance between the Earth and the Sun. That's going to set the Earth. The year is going to be set by the Earth-Sun distance, and a month is going to be set by the Moon-Earth distance. And so if we want to change the number of moons in a year, we need to change these distances. And for those who are unfamiliar with orbital mechanics, I'm showing you a little, yeah, thank you, Noah, for raising your hand, being honest. This is a simulation, this is a GIF of orbits of the 4 innermost planets in our solar system. And the scale, the size aren't to scale, but the time is to scale, roughly. And so you'll see that Mercury is going around faster than Venus, which is going around faster than Earth, which is going around faster than Mars. And so the takeaway from this is the closer you are to the thing you're orbiting, the period will change, you'll go around faster. And so if we want to change the times in a year or a month, we need to change the distance of the thing that it's orbiting.
This is not a joke, just an actual question.
Please.
Because this is basically Astronomy 101 for me.
Yeah.
Does the I guess, radial distance of a stable orbit determine the speed that it goes around?
Yes.
And it can't be anything else because otherwise it wouldn't be a stable. Okay,
exactly.
That's really interesting.
Mr. I don't get
Please
orbits.
go ahead.
Yeah. Well,
I'll
hey.
put my hand down if you ask again.
Thank you for repeating my point so succinctly.
Okay.
Great. So can we change the Earth's orbit? A lot of things about the Earth's orbit do change. These are changes in the shape of the orbit and the tilt of the Earth and where that tilt is pointing all change over 10,000 and hundreds of thousands of years. But the distance doesn't change, and that's really stable, and that's generally good for us on the surface of the Earth. So the year stays the same. We're not going to get to change that at all. But the distance from the Earth to the Moon does change, and we know it's changing right now because the Apollo astronauts, they left a mirror on the surface of the Moon, and here on Earth, we can shoot a laser at that mirror and measure how long it takes for that light to come back to us, and it can tell us that the Moon is moving away at about 3 inches a year. And if you were to go to the exact same spot as the Apollo astronauts, you will travel 6 feet further away than the Apollo astronauts did.
Is that why we haven't been back?
Yeah, it's just that was the budget. They were like,
Have you seen gas prices?
Yeah, 6 more feet, no way. So we know
it's a whole GDP to fill up my liquid oxygen tank. That's for the rocket scientist in the room.
Nice. Right, so the Moon is moving away right now, and we actually have evidence that the Moon was closer in the past. We know that it was closer. And I'll just quickly go through some of this. And the reason we know all of this is because the Earth is fucking with the Moon, or the Moon is fucking with Earth every single day in the form of tides. Right? The tides, the ocean's movement is happening every single day, twice a day. We get these big tides. And so here's a little visualization of the tide. We've got the Moon over here on the right, and we've got a bulge pointing towards the Moon, and there's also a bulge pointing away from the Moon. And that can be a little unintuitive to folks. So the way I always like to think about it is that this side's attracted, and then this side's jealous that this one's attracted, and so it acts out and goes the other way as well.
I also, the Earth moves a little. Right?
The Earth does move.
Yeah.
The Earth is spinning as well.
Yeah.
Yes.
Whoa.
No, I mean, hot take, the Earth is moving in space.
Yeah.
But I remember learning in tide school that
Not laundry.
No, that it's also that the Earth gets tugged a little bit away from that side of the water.
Yeah. Yeah. So there's because this is hard to do from one reference frame. Everything's moving around, but there is a bulge on either side is the main takeaway here. And because there's one other thing about tides we need to know is that there's not just tides from the Moon. There's also tides from the Sun as well. They're much weaker. They're about 1/3 of the strength. But it means that when the Moon and the Earth and the Sun all align, that tide's going to be stronger, and it's called a spring tide. Don't know why. And then when they're not lined up, it's called a neap tide. Don't know why. Sorry, this was the facts show. I should know why. Anyway.
Neep. Does anyone know what neep means?
It means weak.
Sure.
Does it?
Yeah.
No.
Oh.
But in this context, it means weak.
Absolutely.
They're like, do you have a cool name for it? And they're like,
Neep.
Exactly what happened.
Where the tides say neep.
So the point here is that over the course of a month, the tide strength will change, all right? And so that's also information that's important because while we might not notice it, mollusks really do notice it, all right? And in fact, most of our information about the moon comes from understanding, from mollusks, from their shells. And it's because they're constantly growing their shells and they're really sensitive to temperature and water changes. And so, for a kind of a bigger example, you can think about summer versus winter. In the winter, it's going to be colder. They're not going to be able to grow as much. And that's what these darker bands are here on this clamshell. And when it's summer, they get to grow a lot. And so you can actually date the age of this clam by the number of years. And if for certain species, they're so sensitive, they're growing so often, that when there's a spring tide as well, they'll grow a little bit stronger. And so with these artifact mollusks, we can see kind of spring tides and the number of months in a given year. And all of the shells that we've looked at say there's a different number of months in the past. You can do the same thing with the rivers, deposits of silt along a riverbed. If there's a higher tide because of a spring tide, there'll be more deposited, and you'll have to have some seasonal thing there as well. But all this information, again, in the past, there have been a different number of months. There's another thing with geology, which we don't have time to get into, but you can take all of this data, and you can put it onto a single plot, and this is a plot that I made. And over here is present, this is where we are right now, and this is years in the past along the x-axis. And on the y-axis is the number of months in that year up to this different data. And I did something very scientific. I drew a line through it. But then I compared my line to some other work from people who, they weren't looking for number of months, they were trying to figure out how far away the moon was, but I extrapolated from their work.
Pretty accurate.
Yeah, it is. I think I did a good job. And we can point out to these periods where there were exact number of months in a year. Do you guys want to check out what these parties were like? Yeah! Let's check out the 14th month party! Woo!
Really?
I just realized you were holding your breath.
Yeah. And I just realized that's going to make a terrible podcast. So I completely forgot about
We'll stay around to do pickups after.
Okay. All right, so that party's a bit of a wash, but we can go to the 13th month party, right? Do you guys want to check that party out? Yeah! It's only a little bit better, okay, because it's a pool party. And yeah, okay, people like pool parties here. These are the folks who are hanging out. The issue with pool parties, though, is that there might be kids in the pool. And
I thought everyone was going to join.
Yeah. All these Tiktaalik-looking motherfuckers are amphibians, and so they are still laying their eggs in the water. And so it's
pretty neat.
Yeah. Sorry. It's not the best party. It's not the best party. But there is still one more chance for us to have a party because we can carry this trend forward in time to the future, to the 12th 12-month true Happy New Year, right? Think about it. Every month can just be done by the moon, right? Full moon, start of the month, right? The New Year's party under the full moon, it's going to be sick. It's going to be so great, right? Yeah. So it's in 252 million years.
Yeah.
We can wait.
Oh, yeah. And so when I wrote this paper, I did include a section where it's like, okay, yeah, we're going to have to wait for this 252 million years. But I think it's important because, it can be kind of pessimistic thinking about our current society and our civilization, but it's a little optimistic to think that such a human core trait of making up an excuse to have a party might exist for astronomical timescales. And the one thing we do know about this party is that the tectonic plates are going to continue to evolve, and in 250 million years, we're back to another Pangea. So everybody can be there, and there's a little heart in it. That's great. So everybody, please come to my party in 250.
So next up, I'm very, very excited to introduce Dr. Moiya McTier.
I'm going to be talking about the fact that there is a naming problem when it comes to dark matter. So dark matter and names matter tonight. Of course, I'm going to start, with a brief little history of how we have understood the composition of the universe. And I'm going to go back a few thousand years, where for a long time we just didn't really know what was happening. A lot of people either didn't ask what things were made of, or they were like, well, there's God stuff, and then there's us stuff, and we're going to play with the us stuff. And why think about anything else? But around 400 BCE, before Common Era, this dude Empedocles, with some contemporary thinkers, imagined that there were these four basic substances, the four basic elements: earth, air, water, fire, and all of the things that we see, all of the us stuff, is made up of different combinations of those four things. Very soon after that, just 50 years later, this guy Democritus is supporting the idea of atoms, atomos. These are the most basic building blocks of everything that could exist. They are indivisible. That's what atomos means. And he was promptly ignored for 2,000 years. Because of Empedocles, we were plunged into a dark time of elemental mysticism that we could have gotten out of because of Democritus, but no, everyone was like, an atom, that's ridiculous. Obviously, everything is made of these four elements. Aristotle came along and he added the ether, the stuff that the universe might be made of. But for 2,000 years, we were like, yeah, everything is just these 4 or 5 elements. Until 1803.
Wow.
I'm not joking when I say 2,000 years. This is when the first person, for the first time, John Dalton, proposes something that is akin to our modern atomic theory. He's like, there are these tiny little indivisible pieces of stuff, and we can understand their structure, and we can understand how they combine to make different things. And thanks to him, we then entered a phase of understanding what matter is. We were like, okay, we understand that it's not just God stuff and us stuff, and it's not just these 4 elements. We know about the physics of matter. And then in the 1970s, the universe was like, psych, nah, you don't understand anything. Actually, most of what you've seen is a type of matter that is very rare in the universe. This is when we got, for the first time, empirical evidence that there's dark matter, matter out there that can interact gravitationally, but we can't see it. The empirical evidence that got everyone to agree dark matter was a thing came from Vera Rubin studying the rotation curves of galaxies. So she was studying how fast are stars moving at different parts of the galaxy. And we would expect that stars further out, thanks to the Kepler lesson that Mark gave us, we would expect that stars further out are moving more slowly. But what we see is that they're moving faster than we expect. So there's some mass out there because, again, thanks to Mark, we understand that... Yeah.
I'm just lobbing them up and you're knocking them out of the park.
Thanks for the assist. Thanks to Mark, we understand that the speed at which you travel in an orbit is based on how far away you are from the thing and also the mass of the thing in the center. And then we were rocked. We were like, oh, we don't understand matter at all. And then even more than that, in 1998, we realized that the universe isn't just expanding at a constant speed. It's getting faster. That's something that shouldn't happen according to what we understand about the laws of the universe. So there must be something extra, this other force that is propelling the accelerated expansion of the universe. And we learned that we really know nothing. And so now we understand that this is the composition of the universe. It might be a little hard to see, but about 5% of it is visible matter. Astronomers or other physicists might call it baryonic matter. That's just regular stuff like you and me. We interact with gravity, we interact with light, we interact with all of the fundamental forces. 27% is dark matter, which is matter just like us, but we can't see it. And then most of the universe, 68% is dark energy, that force that is propelling the universe's expansion. And they're not going to tell you this in school, but there's a very, very tiny fraction of the universe that is held together by the egos of scientists. And they don't want you to know this because it would underpin the entire galaxy,
Yeah.
and then it would fall apart.
I'm
So-
surprised this platform can hold all of our egos right now.
Yes. It's because we're well balanced.
Well, our heads are so inflated that we actually are counteracting the weight.
And so you're saying if you're not on this stage, you don't matter?
Ooh. Yeah.
But you might energy if you're not on the stage. It's important to remember that in this context, matter and energy are not the same thing, despite what Einstein might have you believe. Here, dark matter and dark energy, very different things. Dark energy is the force that is making the universe expand faster than it should be, and dark matter is the stuff. It's the stuff in the universe that we just can't see. And it has gravitational force. That's a really important point, because the only way we can study it is by seeing how it influences things around it, how it moves stars, how it moves galaxies. But we don't know what it is. We've spent the last, 50 years trying to figure out what is dark matter made of. And there are some criteria that a good dark matter candidate should meet. So you cannot interact with light, with the electromagnetic force, and we've also observed that dark matter doesn't really interact with cosmic rays. Those are these really energetic particles that pass through us, actually. They pass right through us. Most of them pass right through the Earth. But they're zipping around the universe all the time, and they don't seem to be affected when they pass through dark matter. It also has to stay relatively cool. What we know about dark matter now and how it contributed to the evolution of the universe is that it was very present early on. The early universe was much hotter than the current universe, and in order for galaxies to coalesce and come together, they needed a cooler scaffolding to build onto, and we think dark matter was that cool scaffolding. It also has to be really abundant. 27% of the universe is made of this stuff. 90% of the matter in the universe is dark matter. So that's what we're looking for when we're looking for a dark matter candidate. And the particle physicists, they've been busy. They have been coming up with a lot of different ideas. So one of the potential dark matter candidates, actually one of the first ideas for what is dark matter that was proposed, is something called a MACHO, a massive astronomical compact halo object. These could be primordial black holes. In fact, at first it wasn't called dark matter. It was called something in French that I'm not going to try to say. But it was, first it was called dark bodies when we first started noticing that there were discrepancies in how things moved in space. That got translated into French, and then that got translated back into English as dark matter. So these machos could be black holes. They could be big invisible particles that we don't know about yet, but this has kind of been debunked. We are pretty sure that dark matter is not a bunch of Johnny Bravos out in the universe. Then there was another idea. We were like, maybe, let's swing to the other side. Maybe dark matter is a bunch of weakly interacting massive particles, or WIMPs. And there were a few different particle candidates in this, but they don't really interact through the fundamental forces, through like the strong and weak nuclear force, and that's why they're weakly interacting, and they don't really interact with themselves. But we couldn't come up with any good particles that we knew of that would meet these criteria. So then we decided that we have to just make up a new particle if we really want to understand what dark matter is. And up until now, up until the 70s, all of the particles that we knew about fit into this little picture. This is the standard model of particle physics. There are Higgs bosons, there are photons, there are baryons, there are mesons. There's a bunch of different types of particles. But there was a problem with this model, and the physicists called it a CP problem, which is already a little sus to me, because we do know that particle physics had like a CP problem. Yeah, we know, like there were not enough CPs in particle physics, but that's not what they meant when they said CP problem.
Oh no.
Their CP problem stood for the charge parity problem. Basically, particles were too symmetrical in the universe. So they decided to create this law where particles have to be symmetrical, and if they're not, then something breaks, and when that happens, a new particle is created. This idea, this solution to the CP problem, was come up with in 1977. They said that this particle that's produced when this rule is broken, and it should be broken often, it would be a very light particle, and it would be so abundant because this rule gets broken all the time. So it's a good particle candidate for dark matter. And we had some ideas for what we could call this particle. Someone said, let's call it the Higglet, which is really cute. Like, that's an adorable name, and it invokes the Higgs boson, which some people call the God particle. It's this really important thing in particle physics. And then this dude named Frank Wilczek, probably, I didn't want to look up how to say his name, he decided, there's a C and a Z in there, and I don't care.
Okay.
Because this man decided to solve the already suspicious CP problem with a particle that he thought should be named after a Latin American soap. He was like, let's name this particle after a soap brand from 1968 that you can now only find in Latin America because it cleans up the CP problem. And I can't be the only one who sees an issue with this, right? Right? Like, there's something suspicious. It's a little hinky, right? Like, I don't think they did this on purpose, but it's definitely a naming problem. And I am not the only one who has noticed this. There is a very well-respected particle physicist and cosmologist, Dr. Chanda Prescott-Weinstein. 2 years ago, she came out with this book called The Disordered Cosmos, which I highly recommend. It talks about cosmology, it talks about theoretical particle physics, it also talks about the social issues in astronomy. And one of the things that Dr. Prescott-Weinstein has been pushing for a few years is changing what we call dark matter. This is a plot in the book of hers that shows all of the different potential candidates for dark matter, and all of them have a naming issue because we're calling it dark matter when we should be calling it transparent matter. It's not inherently dark. It's invisible. We can't see it. It doesn't have a color. And calling it dark just because we don't understand it, while not explicitly racist, is still a little bit fucked up. Because it's something that we use in a lot of science where if we don't understand what it is, we're like, well, that's dark. That's the dark thing. That's the black thing. And then we continue to have things like CP problems in physics. So, my whole takeaway from this talk is probably read this book and be an evangelist for calling it transparent matter instead of dark matter, because not only is it kinder to the people who study this, but it's also more accurate as a description. It is not dark, it's transparent. Thanks.
Please, everybody, first I want to say, please give a round of applause to very soon-to-be Dr. M. Costa.
Yeah!
Who is, I'm sorry, I think it is a foregone conclusion, and nobody knock on wood. M is the third host of Fax Machine, not in this show tonight because she is currently writing her thesis. She actually defends her thesis the day after our next show in February. So the next show is going to be just wild. So please, again, give her lots of appreciation and thanks and well wishes on the way out. I really appreciate that she's taken time out of her busy writing schedule to help us grade. Thank you so much, Em. All right, so here is the trivia results. Backstage, our guests did the same trivia that you all did. Let's find out how they did.
So good.
Mark, Moiya, Rob, how do you feel?
Great. Always.
Great.
Yes.
If there was a word for confident, I would use that.
Okay.
Do you need the thesaurus
Yeah,
back?
do you have one? Question 1. French physicist Etienne Klein released this image of what type of object, adding incorrectly that it was the most detailed image of the object ever captured. That object was a sausage.
Were we not supposed to try an answer?
It was a chorizo sausage. Is that? I'm seeing somebody like frantically waving at me
Noah?
because I said what?
Were we not supposed
we knew
to
that.
answer?
Yes. So, what was it?
Let the record show we wrote that down.
We
too,
did. We
before
wrote-
we heard it.
We had sausage, and then words you weren't going to take it, we wrote in brackets chorizo.
Yeah.
This is not a German-style sausage.
No. So basically what happened here is that Dr. Klein sent out a tweet that this image was of a star, specifically the star Proxima Centauri, which is located a mere 4.5 light years away. However, he followed up to clarify that his post, which was liked tens and tens of thousands of times, was actually a hoax, and that in fact the image was of a chorizo sausage, adding, quote, "According to contemporary cosmology, no object belonging to Spanish charcuterie exists anywhere but on Earth."
As far as we know.
As far as we know. I did actually look up, there are many, many more detailed pictures of sausages than this. People have used scanning electron microscopes. I didn't have time to put them in there, but you can look them up. There's a lot of food safety papers where you can see really,
Be careful with that Google search.
Yeah.
Incognito.
I want to see the inside of a sausage.
R.I.P. to your search histories.
Yeah. So, question 2. This time I'll give them time.
Thank you.
True or false? Apollo 12 astronaut Pete Conrad fumbled his NASA-prescribed first words on the lunar surface as follows. Quote, "One step further for, step into the future for mankind, humankind." Well, so is that true or false?
That's a great line read from the start.
Thank you.
Yeah.
Yeah.
Well
Do you
done.
want me to do it again?
I just want I want the hot well again because I thought that was really good.
Well.
Yeah, nice.
Or in the immortal words of John Young, ah, shit.
I don't think Pete Conrad is a real astronaut person.
Yeah, we think it's false because Pete Conrad doesn't exist.
That's an interesting, because you did get the question right. It is false, but Pete Conrad very much is an astronaut.
Oh.
Yeah.
That is not the false thing about it.
I also
Sorry,
think
Pete,
Apollo
if you're
12 is
listening.
a dumb number and should be an odd number. Yeah,
The
that's what I
false
thought.
thing is that's not what he said. What he said was, whoopee, man, that may have been a small one for Neil, but that's a long one for me. This is what happened.
Yeah, and you wonder why he was the second first
Yeah,
person on
exactly. So basically, this reporter bet Pete Conrad $500 in an interview that NASA wouldn't let him say whatever he wanted to say for his first words on the surface because she didn't believe that Neil Armstrong came up with that phrase and thought that NASA had workshopped it and told him to say it. So what he did to prove her wrong was that he decided to make his first words, "Whoopee, man, that may have been one small one for Neil, but that's a long one for me," partially making fun of the fact that Neil Armstrong was a lot taller than Pete Conrad, and it was also extra funny because there was apparently some sort of missing rung or something on the ladder, so he did fall really far.
But it's on the moon where the gravity isn't as strong, so he didn't
Right.
fall as hard.
If you want to have a blessed search history, look up astronauts falling on the moon. So many astronauts fall on the moon. They're out there for 20 hours a day picking up rocks and shit. They are always on their ass. It is amazing. So this is just the last one on this one. Pete Conrad's wife, Nancy, wrote, quote, "Pity the twit who would try to script a bunch of test pilots with fighter jocks, egos fully intact, riding a rocket to the moon." That was almost blank verse.
That's great.
Yeah. I don't know. Maybe they should have, basically.
Hell yeah.
Question 3. A Norse settlement in North America was able to be dated to 1021 CE due to a spike in atmospheric carbon-14 caused by what type of celestial event that happened in 993 CE?
So I actually know a lot about this because it's
Oh.
in one of my podcast episodes that I'm going to
Oh,
plug in
amazing.
a second. But these things are called Miyake events.
Okay.
And I thought these were still kind of debated about what caused it. So I want to hear what you're going to say and then say that's not it.
Now, okay, I will tell you the Nature paper that I got this from, and it
Good.
may very well be that since it came out and I saw the headline about it in the astronomical literature, it has been contradicted, and we can definitely hear you out.
Nature's
So-
usually wrong.
Yeah.
They have more recalls than other journals.
Yeah.
That's
Fuck
just a
Nature,
fact.
I said. All right, so here is basically the answer. I would have accepted any form of solar storm, solar flare, coronal mass ejection, any of the words that mean that, or something similar to that, because we don't know exactly what it was, but there is a thought that basically there was a spike in carbon-14 content created by the interaction with some sort of solar storm with the atmosphere of the Earth. And what you can do is in tree rings from this archaeological site in, I think it's Nova Scotia or Newfoundland or something, I think in Newfoundland, there was a really wide range of when they thought it was going to be. It was still like 500 years before Columbus, but they were trying to narrow down when exactly these people were here. And basically what they were to do is not even one of the logs that was in the building, but basically like trash wood that they just got out of some sort of like midden. And what they can do is do like mass spectroscopy.
Mass spectrometry.
Fuck.
Just say mass spec.
Mass spec. Yeah. Every single time I say that word, I mess it up and say the opposite one. Sorry. They can do that on the different rings, right? So they're the kind of like we saw with like the oysters or clams, or just sort of shellfish, right? Mm-hmm. Whereas they're growing, right? We all know this. We've seen like rings of a tree. You know, they'll have another one for every year, and they can sample basically the amount and measure the amount of carbon-14 that's in each of those rings, and look for this characteristic spike that has been found at other sites around the world. And so just another thing that was mentioned is that there were historical records of unusual aurora in late 1992 and early 1993 at places as far apart as Korea, Germany, and Ireland, which all describe a blood red sky with a fiery hue that, quote, looked like heaven's gate was opening. So
it's like last June.
Yeah, so this is, yeah, exactly. So basically what they did was use dendrochronology, which is using the tree rings and trying to measure the things and make that connection to something happening in space. Now, Mark, why is that wrong?
No, you're absolutely right. If
Okay.
you want to hear a 15-minute of that conversation, version of that, we have it in a podcast, and we talked to a scientist who has studied this and has modeled it. But one of the, we think it's solar flares, but the thing is, if one of those things, we're kind of due for one. They happen, there's been like 6 or 7 in the last 10,000 years, and none since this date. And so if one of those things were to happen now, all of our satellites are gone, instantly. So if you want to hear more about how terrifying that is, there'll be a podcast about it soon.
Nice. Aren't there like way too many satellites right now? Isn't that a problem? Okay, so
That's
we're
also
due for a
nice.
clear out. Like,
Yeah.
Well, it's not going to get rid of the junk. The junk is the problem. There's just like a
so
lot
they're
of
just
hardware.
I see. They'll just like flicker and die and not just all plummet toward the Earth.
Some
Because
will.
that would be better.
What if they all melt together?
Yeah, into
That'd
a
be
super
cool.
satellite.
Super
Yeah,
roll.
Just give us a second moon.
That's no moon. It's a space station. Okay, question 4. Solar Star. Question 4. Which one, singular one, of the following science news headlines about Uranus did I make up? A. Uranus will be on display for the entire world later this month. B. Scientists just recreated the horrendous substance found deep within Uranus. C. Uranus gapes wide open for blasts of hot wind, scientists claim. That's my favorite part. Comma, scientists claim. This is D. Don't laugh, but we just found something mysterious near Uranus. Or E. How methane plumes and diamond rain are complicating NASA's plan to probe Uranus.
That's real.
You think that
Which
one's
one?
real?
That last one is real.
I just
Okay.
suddenly thought it's not, but let's go with it.
Well, you actually have to decide together. So
Yes.
what
Yeah.
do
That
you think
last one is real.
You okay?
I'm okay with that being real.
Yeah.
I could live in a world with
so
methane
is there
plumes.
disagreement on your team about whether or not it's real?
Yes.
Okay.
But you,
How about
you thought this one was the
Okay,
fake
which one? Well, now I think they're all real, and he's fucking with us.
I don't think Noah's that much of a trickster.
I would never do something like that.
Yeah.
Yeah.
My vote is
Yeah.
that D is the one Noah made.
Okay.
All right, we're going with that.
Okay.
Yep.
E was the one that I made up.
I can leave now. We're almost at the end anyway.
I should have stuck with it. Darn it. Oh, well.
All but E are real headlines from the science journalist Rob Waugh, who clearly loves his job so much and/or doesn't care if he gets fired. And don't worry, there are so many more. For example, another real headline: "There's something very hard heading toward Uranus, scientists believe." "Something huge and hard went into Uranus, and it got very messy." Uranus stinks like egg.
I didn't catch that last bit.
Unintelligible.
That one's snuck up on me. Uranus stinks like eggy.
Sorry, I still didn't quite get it.
Okay. Nobody laugh, all right?
not what you're
Uranus, shut up. Uranus stinks like eggy farts, scientists finally admit.
Our secret's out.
So, moving on. Question 5. Which play by Shakespeare set in Denmark is thought to mention a supernova now named after a Danish astronomer in the very first scene? In fact, Act 1, Scene 1.
Okay, I had an inclination here that this was Hamlet because he's Danish.
And we didn't have any better ideas.
Yes.
Yeah, and then there's something in my brain about the beginning of The Lion King and A Sign and Hamlet.
Yeah.
And then I said all that, and they were still like, cheer up.
Yeah. I just went Simba.
So answer is?
Hamlet.
Hamlet.
Okay, the answer is, in fact, Hamlet.
Yeah.
I spelled it Hamlet.
When yon same star that's westward from the pole had made his course to illume that part of heaven where now it burns. From references to the position of the star and to the climate and time of year, 3 researchers from Southwest Texas State University, 2 from the physics department, and 1 from the English department, really emulating Moia's academic career.
Cross-disciplinary, that's
But
great.
Moiya did it in 1 person. This took 3. Identified the position of the star would have been in the vicinity of the constellation Cassiopeia. Not Cassiopeia. That would be too fancy.
It's the same.
Okay, Cassiopeia. Okay. However, there aren't, according to the article I read, I'm not so familiar with Cassiopeia that I can throw shade on it, so to speak. But they said that there aren't any especially interesting or bright stars in that constellation.
That's so rude.
Yeah, right?
It's the only one that looks like a nice letter that you can spell.
Nice W.
Yeah.
Or M.
Yes.
Yeah.
Perspective is
True.
important.
Northern or southern hemisphere, or can you only see it from one?
I don't think
More
it's
north.
around the ecliptic, so I
Okay.
think probably higher
right.
up.
Well, one of the letters. Or a 3, or a sigma. That's enough. It's
supposed to be a crown.
Exactly. They basically said there aren't any, where it's being described is in that constellation. They know Elsinore Castle, where it's set, is a real place in Denmark. They knew, the description. It was west of the pole, which is the North Star. There were a lot of other references to time of year and different sort of descriptions of the sky at that time. So they could figure out it's probably this one. And the thing is, even though they weren't able to identify any particularly bright, noteworthy stars now, there used to be, for a brief period of time, a brilliant star that appeared in 1572 seemingly out of nowhere to these people who would have been very shocked by that, and remained for about 16 months and gives this idea that the cosmos are not, in fact, like the same, and that there was this massive new star in the sky, and that caused a lot of unease, which is sort of what leads into a lot of these themes that are present in Hamlet. And something really interesting was that it was one of the people to study it most thoroughly was Danish astronomer Tycho Brahe, and he basically, so they call it Tycho's supernova now, and there's evidence basically that his work in particular influenced Hamlet. For example, and there's lots, but I'm going to cut this down. For example, the most famous portrait of Brahe at the time included the family names of his ancestors, Rosencrantz and Guildenstern, which if you've ever read or seen Hamlet performed, are the very, very, nearly identical to 2 important characters, Rosencrantz and Guildenstern. And in addition, Brahe's observatory was on an island just off the coast of where Elsinore Castle is in the Danish Sound, I think it's called, where it takes place. And so there are, I gotta get through this question, I'm sorry. There are a lot more connections that are really fascinating to read, but I just want to bring up one more because it makes me laugh so much, and that's what we're here for, is that another person who influenced Shakespeare's astronomical inclusions in his plays was the English astronomer John Dee, who wrote extensively about that supernova. But because I want to include it because I have a John Dee fact that I just desperately love, and that it's in his private diary he wrote that his son Arthur received a head wound by, quote, his own wanton throwing of a brick, and not well avoiding the fall of it again. The brick weighed 2.5 pounds. Arthur went on to become physician to kings. Question 6, shortly after discovery of Saturn's rings, a Vatican librarian wrote that they were actually what part of Jesus' body ascended to heaven?
I know that Galileo described them as ears in his early journals, but
Okay.
that's not the Vatican.
No, and Rob has a...
I've done a lot of fax machine-y stuff where you read weird things, and in a previous episode, we had talked about parts of Jesus that couldn't be accounted for, and so there's this, and if the Pope, if you're listening, I know you're not supposed to talk about this. Sorry again.
Pope is an avid listener.
I know.
Yeah, friend of the pod.
You have one
That's
listener
why
in Vatican City.
I know
and-
he's sending an
Yeah,
email.
our next live show, Vatican City.
I can see him writing the email now.
Let's get frocked up.
Robertus. But so there's this
Ecclesiastical joke for the priest?
in the in the Catholic Church, there's this problem because at some point Jesus was separated from part of his body near and around birth, which was circumcision, and I'm pretty sure they said that this is his foreskin.
Yes, that is absolutely correct.
Yeah.
There is a debate. There is a debate between people who think that Jesus' foreskin was, there was a debate at least, whether Jesus' foreskin was still on earth where it was buried after Jesus was circumcised.
Academic debate.
Or whether at the moment of ascension, whether it also ascended to heaven.
Yeah.
And the Vatican librarian and scholar Leo Latius, or Latius, I'm not sure, is said to have written an essay entitled De Preputio Domini Nostri Jesu Christi Diatraba, Discourse on the Foreskin of Our Lord Jesus Christ, in which he asserted that the Holy Prepuce, which was a hotly contested relic of the Catholic Church that, interestingly, was said to have been held by more than one church at a time, had in fact ascended at the same time of Jesus' circumcised body to then become the rings of Saturn, which according to M, who has mentioned this on our show before, would mean that Jesus' penis was roughly 170,000 miles wide. That's that big dick Messiah energy. A lot of men think they're the Messiah, you know. But
I am the Son of God.
Also, I just want to say that the Holy Prepuce that the Catholic Church recognized as, a relic that was still on Earth was looted and then recovered during the, quote, sack of Rome, which was an event and not a separate relic. Question 7. Which one of the following cosmonauts participated in a mission to service the Hubble Space Telescope? Was it Valentina Tereshkova, Tokhtar Albakirov, Yuri Gagarin, Svetlana Savitskaya, or none of the above?
Gotcha.
You bastard. That's the one I thought it was.
It really was. And then Rob knows you so well.
Like, I literally heard them say that. I think it's that Nonov guy.
Yeah,
And I was like, wait a minute.
Always read them out loud. I'm a son of a bitch. No Russian cosmonauts participated in the Hubble repair missions, although astronauts from France, Switzerland, and the US did fly on the Hubble repair missions. That was just a mean trick, and I am sorry.
So I was right. It was none of the above.
Yeah.
Hey!
None of the above.
Nice.
Yeah,
Okay.
that's what I meant.
Question 8, we gotta finish up here. In Albanian, it's Godfather's Straw. In Irish, it's the Fair Cow's Path. What is it called in English?
If this is not the Milky Way, I will unsign my book contract.
In Ireland, the fair cow's path is sobriety.
Rob
Am I right?
Before we get letters, Rob was born in Ireland.
The Pope puts his pen down.
Go Margit, Rob. All right, that is in fact the Milky Way.
Yeah.
So many languages have used many names for the Milky Way. I tried to use the ones that didn't give it away right away. There are a lot of them that have way included in the term, even if it's not the Milky Way. A lot of them just use like the Latinized or whatever it ends up being of the Milky Way. And there's of course, as I've said, many languages use a variety of terms, so this isn't like supposed to be the only one used. But some other examples that I liked were in Chinese, the Silver River, Hawaiian. This had a bunch of examples, and I'm afraid that I wasn't able to check each and every one, but I did like the way it sounded of fish jumping in shadows was cool. And then in Medomari, which is a language in Russia, Way of the Gray Goose, and Slovene, the Roman Road, because as pilgrims were said to follow the path of the Milky Way to Rome. So, just interesting. No joke there, just fun.
Nice
fun to learn.
fact.
Yeah. So tonight we have a tie for first place between the astronomers and Sonny and Cher.
Oh, Sonny and Cher.
And then we also, in fact, we always give out an award to the team with the fewest points and call them the team that learned the most. So tonight, in last place, please join me in congratulating Team Third Place. If you raise your hand, we have a prize for both the winning team, the two winning teams, and the team that learned the most that we'll bring to you. That's just about all we have for you tonight. Thank you all so much for coming out. Mark, do you have anything you would like to tell us about that's coming up for you?
Yeah, please follow me on social media. I'm also a contributor to Astronomy on Tap NYC, which is another kind of live speaking astronomy event. Please check out, look us up on the internet. Astrobytes.com is a website that I write daily astro papers. We summarize them for a lay audience, so please check that out if you like astronomy. And then also, I'm working on this podcast, Celestial Bodies. My co-host, Rebecca's in the back there. Thanks for coming out, Rebecca. If you like the kind of combination of astronomy, the whole idea is we're looking at how life affects astronomy, or astronomy affects life on Earth. We have a similar story about the mollusks. We have a story about these tree rings that you've heard about, and how space is part of life here on Earth. So please check that out, coming out in a few months.
I love it. Hell yeah. Please go listen to Celestial Bodies. Go to Astronomy on Tap. It's very cool. And also read Astrobites. Moya, is there anything you would like to share with us?
Yeah, I'm Go Astro Mo on all the socials. I have a book called The Milky Way. Some of you will see it very soon. I have 2 podcasts. One is about fictional world building. It's called never mind. One is about fictional world building. It's called Exolore. The other is about space, but for people who are afraid of space, and it's called Pale Blue Pod. I want to be its friend.
Yeah, it's really good, everybody. Please, both Exolore and Pale Blue Pod are like 2 of the podcasts I like every time an episode comes out. I'm checking that out. And also, Fate and Fabled.
Yes, Fate and Fabled is a PBS Digital Studios show, and we cover mythology stories from around the world, connecting it to the modern day.
All right. Please join me once again in thanking our guests, Dr. Moiya McTier and Dr. Mark Popinchalk. And just for fun, give me a sarcastic round of applause for my co-host, Rob Frawley, Dr. Rob Frawley. Sounded a little genuine, gotta be honest. But if you like the show, please listen to it, rate and subscribe, all of the above. Very last thing, starting next month, we will be here on the 3rd Thursday of every month, so please come back, see us. We'll have some impossibly difficult trivia that you can be very frustrated at me about. So that means our next show is Thursday, February 15th, 7 p.m., right here at Caveat. So join us for a science comedy show and a science trivia showdown, loosely inspired by the science of love. We will be joined by neuroscientist Dr. Paula Croxon and chemist and soon-to-be Dr. Adam Rosenzweig. So it's going to be a great show. So last thought I want to leave you with tonight. Astronomy helps us to look up into the night sky and imagine what our lives could be like on extraordinary, fantastical new worlds. But for our part, we wouldn't choose to be anywhere else than right here with all of you. So thank you very much for coming tonight, and see you next month.
Wow.
And give it up for Noah!